Hi, it's Bruce. Welcome to my Colorado Rocky Mountain lab. And today I'm taking a look at a Fluke 8810A. This is a 5.5 digit digital multimeter, measures DC volts, AC volts, and ohms. Covers ranges 200 millivolts DC up to 1200 volts DC. Or 2 volts AC up to 750 volts AC. And on the ohms, we cover 200 ohms up to 20 megohms. We do that in 6 ranges. And we are one less range on the AC. It's got on the 200 millivolt and 2 volt DC range, you have an input impedance of about a gig. And otherwise you are, I believe, 10 megohms of input impedance. The unit is in good looking condition. It's clean. No ridiculous scratches or anything on it. We have a little dent on the corner here. Looks like somebody might have bumped it or possibly dropped it at some point. Hard to say. The stand is in good shape. The handle got the original specs and so on the bottom here. Rubber feet. Okay, we've got, look at the back here, it's in good shape on the back, cord will come with it. So essentially that's the walk around on the unit. We will take you through the operation of the unit and verify its calibration. So bear with me and we'll get that thing started. It's been given a home calibration here. I've got some nice equipment for calibrating the unit, and I have a calibrated Hewlett-Packard 34401A that I use as a standard just to kind of check things out. And bear with me, and we'll get started. Okay, so we've got 1 volt coming in. We're either flashing all 9s or 1 and all 0s, and that's exactly what's happening here on the Fluke as well. So at 1 volt on the 2 volt scale. Looking good. We're going to go to the 20 volt scale. All right, we've got 10 volts AC coming in, and we're reading 10 volts of AC within 100 microvolts anyway on the 20 volt scale. Going to the 200 volt scale. Okay. Reading a little light on the low end, very low end of the 200 volt scale, like 1/20th. But let's go ahead and boost her up. Okay. And then adjusting. Okay, there's 100 volts to a millivolt right there. And we're on the 100 volt scale, we're reading 100 volts to the millivolts. So on full scale, we're looking real good. We're going to go to the 2000 volt scale. And 99.9. Again, just a little light on the low end of the 2000 volt scale, but we're reading it. Volts, 99.9. Okay, let's go ahead and take a look at the DC range, see how we're doing. Okay, we're on the DC scale. We're putting in 100 millivolts of DC, and we see it, all the way down to the microvolt. And we have 100 millivolts down to somewhere between 2 and 3 microvolts. So we could be a microvolt or so off, but it's very close. Going to the 2 volt scale, There's 100 microvolts, or 100 millivolts, excuse me. That's at the low end, and then we're going to go pop ourselves up to the 1 volt scale. Okay, we're on the 2 volt range. We've input 1 volt DC from that 343A, that's the precision power source. And we're getting 1 and 5 zeros essentially on the meter here, and we've got 1 and 6 zeros on the HP. So we're good at 1 volt. Let's go to 20. All right, we're picking up all 9, so essentially 1 volt on the low end of the 20. That's 1/20th of the scale. And then we're going to go to 10 volts. So we got 10 volts, 10 with 5 zeros essentially. And we're getting 10 with 4 zeros. So plus or minus a digit. Looks like plus a digit. So it's flashing, but it's good. All right, so let's go to the 200 volt scale. There's your 10 volts. All 9s to 10. And if we go to 100, and we adjust for the 100, all right, that's 100 with 3 zeros, so that's right to a millivolt, and we've got 100 with 3 zeros, right to a millivolt. So, okay, so I moved up to the 2000 volt scale. I only feel comfortable playing with 500 with these test leads and such. Really not too sure that they could handle 1000 volts without arcing. But we got 500 reading right on the HP, 500 volts, and we got 500 on the Fluke. So it's a decent range of the scale. Let's move on to the ohms. This thing is tracking very, very well to the HP and DC here. Let's go ahead and move on to the ohms and see how we do. Okay, so we've moved into ohms and we're on the 200 ohm scale. Right now I'm feeding in from this resistostat 2. It's a 0.01% device, so very precise. Right now we're putting in nothing. It's all zeros on the dial, and we're essentially reading the resistance of the leads, and we're getting 0.142. So let's go ahead and add 100 ohms. That'll put us mid-scale, and it happens to be a calibration point. So we're getting 100.132, so we are 0.01 ohms in difference to the, what I did is I backed out the 0.142 out of the number we got here, and we wind up with 99.09, so we're about 0.01 ohms low. Let's go ahead and go to the 2 ohm scale. Okay, and we'll go, I said 2 ohms, excuse me, 2000 ohm scale. And we're going to go to 1000 ohms. And there's 1000 ohms to 5 digits. Let's go to the 20K scale. There's your 1000 ohms. Let's go to 10,000. Okay, so we're on the 2K scale. We've got a 1K chosen off of the resistostat. We're getting a reading of 1, 4 zeros, and a 1. So we are about 10 micro ohms. Well, would that be right? Let's see, this would be ones, this would be tenths, hundredths, excuse me. So we're 1/100th of an ohm different than the resistostat. And let's go to the 20K scale. We're reading 1K, which is good. We're going to go That's 11, and then we're going to back off 1. So here's 10K, and we've got 10K reading all 9s to a 10. That's good. Let's go to the 200K scale. We're reading all 9s to a 10, and this would be 100K. This is mid-scale. All right, we're reading 5 9s, so and it just flashed to a 10. So we're somewhere right on the cusp. And that would be less than an ohm difference out of 10,000. And let us go then to the 2 meg scale. All right, we're reading approximately 100 ohms. You're getting a little bit of noise because of the impedance of the scale. Let's go to 1 meg. This would be mid-scale. All 9s to 1 meg, so 999,099 to 1 meg. All right, let's go to the 20 meg scale. All right, 0.999, essentially 1. Go to 10 meg. This is the mid scale and also the noisiest, hardest to read scale. All right, all 9s roughly. So, and there's a 10. All 9s to a 10. So, perfect. So we're reading ohms very, very well. So we've done DC volts, AC volts, and ohms. And the unit has performed quite well.